Let's draw the shear force and bending moment diagram for this frame with an oblique member. And by vertical equilibrium of forces, we have 2 kilonewtons acting upwards, and horizontal equilibrium of forces, we have 1 kilonewton acting to the left. And because it's a fixed support, we have a moment reaction. So by equilibrium of moments about the fixed support, with anti-clockwise being positive, we have minus 1 kilonewton by the moment arm, minus 2 kilonewtons by the moment arm, which is 4 cosine 30 degrees. And plus the moment reaction is 0. And if we draw in our special trig triangle for the angle of 30 degrees, we have root 3, 1 and 2. So therefore cosine 30 is the adjacent on the hypotenuse. And our moment reaction is 3 plus 4 root 3 kilonewton meters. And now let's draw our shear force diagram over here. Well, what we do is resolve this 2 kilonewton force into a component that's perpendicular to the beam. And this angle here is 30 degrees, and so is this one. So this component of the force is 2 cosine 30 degrees, or 2 root 3 on 2, or root 3. And now if we cut the beam as follows, the shear force is root 3 and constant along that beam. And at the bottom we have a horizontal reaction. So if we cut the column as follows, the shear force is 1 kilonewton and constant in that column. And now we'll draw in our bending moment diagram. So the bending moment in the beam is root 3 by the moment arm, or 4 root 3, and varies linearly along that beam. And at the joint there's no externally applied moment, so the bending moment in the beam is the same as that in the column. And the bending moment at the support is equal to the moment reaction. So that will be 3 plus 4 root 3 kilonewton meters. And the bending moment here varies linearly along the column. Please subscribe, like and comment to help me reach more students.